So this is our first exercise of scaling. In this scaling, what we do, this is our question, that given I have this diagram, okay, with the vertices of 0, 2, 2, 2, 2, 0, I want you to apply the scaling factor 0.5, 0.5, scaling factor 0.5, 1.5, scaling factor of 1.5 and 0.5. So these are the three operations, and these are the results of these three operations. This is the result of first operation, this is the result of second operation, and this is the result of third operation. Now we will see how this operation took place. So first of all, in the scaling, you have to understand that these are called scaling factor. That means Sx, Sy. So whenever we start with the diagram, we'll actually multiply this Sx and Sy with every points on the diagram. So instead of multiplying with every points, now we are only working with 4 points, the boundary points. Why? Because if you just can find out the boundary points, okay, that if I can find out that what will be the new boundary of this 4, okay, this 4 boundary of this rectangle, I can actually just connect those boundaries and draw the whole picture. Okay, so first of all, 0.5, 0.5, what does this mean? This means it will be half half. That means the new diagram will be half of this diagram. So if I just multiply with this half with all of this, so half into 0 is 0, half into 2 equal to 1, half into 2 equals to 1, half into 2 is to 1, half into 2 equals to 1, and half into 0 into 0. So basically I have multiplied half with this, and this. So basically in this way, I can get this new diagram where you see the image actually shrinked in size. That means the size actually decreased, became smaller. Let's go for the second one. It will make things more clear. So remember, the first one is half is x and the second one is y. So that means in the x-axis we'll multiply with half, in the y-axis we'll multiply with 1.5. So again, if I multiply in the x-axis with 0.5, so 0 into 0.5, 0, 0 into 0.5, 1, right? Sorry, again, the mistake here. We are not multiplying the y-axis. We have to multiply only the x-axis. So 0.5 into 0 is 0, 0.5 into 2 is 1, 0.5 into 2 is 1. 1.5 into 2 is basically 3, so this becomes 3. 1.5 into 2 equals to 3, so this became 3. 1.5 into 0 equals to 0, so this is 0. Let's go for the third one. 1.5 into 0, 0. 0.5 into 2, 1. 1.5 into 2, 3. 0.5 into 2, 1. 1.5 into 2, 3. And 0.5 into 0 equals to 0. So basically, we have multiplied all the points with this this scaling factors. Now this one actually easy because we can see the points, right? But problem is whenever we are actually working with a huge picture or a complicated picture, so whenever we are working with a huge picture or a complicated picture, these points are actually not available. Okay, or it might be difficult to find all these points. Okay, you might have a, let me just clear this. You just might have a image like this. Okay, no axis will be mentioned and you will just have a box like this. And you will be asked that if I apply these scaling factors here, what will be the new size or the new position of this rectangle? So in that case, it actually becomes complicated because now you actually don't have any idea about these points. So how can I actually multiply by point? And that's where actually vector helps. So if I actually go back to our previous slide, let me clear the drawing. So the drawing is cleared. So here, what we will do, we will actually take a matrix that is our object. So here, as you can see, P is an object. The location of the P is X, Y. So what we will do, we will create a matrix of X and Y. So this is our matrix, okay, X and Y. This is the scaling factor, Sx and Sy. So the first image that we did, okay, it was 0.5, 0.5. So this Sx will be 0.5, this Sy will be 0.5. And the result image, that is P prime, will be X prime, Y prime. So instead of thinking by point, what we can do, we can take a matrix and we can multiply that matrix with the scaling factor. Now you might ask me, sir, why we're actually taking a matrix? Why you're doing so much hassle? One reason I have just told you, that sometimes we actually don't have any idea about the points. Secondly, if you remember, whenever we're actually drawing a picture in the image, so in that image, we actually have, so as I was saying, that when we have actually drawing an image, we actually have a frame buffer, and that frame buffer is actually a collection of ones and zeros and zero matrix. So we can easily represent a frame buffer that is a collection of 0, 1, 0, 1 using a matrix. So you have already know what is a matrix and how matrix work. So we'll go to further discussion later. But today, let's just focus on how scaling work. So I hope it is clear how scaling work. And let's go back again. So in this scaling, okay, if I multiply with 0.5, 0.5, okay, what happens? It actually becomes smaller. And if I multiply with values with larger than 1, it becomes larger. And if I actually mix things up, okay, the one that we did, you see, one was 2, another one's 5. So the shape actually changes. Okay, so the zoom actually happens on different way. So this is all about basic scaling that you need to know. So here is another object where there is no coordinate given, but we know if we apply scaling with the help of matrix, we can actually easily change the size of this one. Now we will finish the scaling here. Now next we will start another topic, the rotation.